Okay, we'll get started.
Yeah, it's stuck.
Everybody's busy doing the first problem? Mm-hmm. Good.
So like all of the states have some invisible transition to a reject state. Okay.
Yeah, how the recitation for these two problems, because nobody volunteered for it during the class. So I have to explain it. So how do we start from writing a Turing machine? Turing machine is kind of closer to the real computer in our sense than the other like context-free grammars and the other things, right? So basically, before you write the Turing machine for a certain problem, you start thinking about the algorithms to do with it. What's a computer? Computer takes input and gives output, and wherever in between is an algorithm. So what's the input of Turing machine? String, yes, but more precisely, it's a type. String on a type. So, for example, we have A, B, B, C, C. And besides the type, what else do we have? We have a head pointing at the beginning of the type. And we have some blanks that denotes the begin and end of the string. And yeah, basically your Turing machine is to describe with the type. How do you recognize the string on the type belongs to the language that's required? So what do you do next? You think about an algorithm, right? So say if you have a string and you want to see whether it matches certain pattern. Let's say the first problem, AN, BN, CN. What's the algorithm? Nico actually described it already. Would you say it again? No? No, that's correct. So you want to guarantee that you have the same number of ABCs. And what Nico just said was you start reading the tape, and if you see the blank, then it terminates. It means the empty string, and empty string trivially has the same number of ABCs. If you see B or C, then you terminate and reject because it's not of the form. So it must start with an A, and if you see an A, what do? You cross it out with some symbol, say X, meaning that you erase the A from the type and replace it with the X symbol. And after you do that, you go to the B part. You keep reading right until you see a B. If you don't see it, then reject it. If you see a B, then replace with a symbol saying I've seen one B. Then keep reading, keep going right to find the C. Same thing here. If you see a C, cross it out. What do you do next?
Advance to the right.
Do you keep going right?
If you cross it, you go back. Right?
So if you cross one C, then you go back to the beginning and repeat until when do you go back? Then when do you stop going back? If you see B, you go right, left. Sorry. If you see Y, you go left, right? If you see A, you go left until you see X. Then repeat the same process. That's the algorithm. Now, can you describe this algorithm using some state and transitions? And sorry, I think, yeah, I haven't finished. So you keep doing, you keep iterating. When do you stop?
When you see an X.
when you don't see any A. So when you have, for example, Y follows X directly, then you stop because you read no more A's. Then how do you find the string is valid? You keep going right to see whether you can still find B or C. If you can, then terminate, say reject. If you cannot, meaning that if all the remaining string is Y, Z's, eventually you will reach a symbol blank. Yeah, if you keep reading, skip all the Y and Z's. If you see a blank, then you accept. Otherwise, reject. Make sense? Okay, now what's the state diagram? Do you want me to write it or somebody is already trying it? I have my secret now. Bless you. Should I, or do you want to try? Moody?
I can try.
Sure.
Thank you. Should I try to here?
Try it here because that's the only place it's recorded.
Can you remind me what the transitions look like? So it was. This is the input string, and then.
Right. If it's a blank, then you should accept. Right.
Right.
If it's an A, then you cross it out, replace with a symbol, and then.
So I'm gonna write if it's blank here, then I have to go right, I guess.
Yeah, something like that.
And here Q accept. But what was the second one? Oh, I don't have to write it, right?
Yeah.
I can just do this.
Right.
Okay. So if it's A, and I replace it with X, and I go right.
Right.
So it's A, go right. So if it's B, put Y, and I go right.
Let me do this way.
Until I find go left until I find an X. So I kind of have to do this. So do I write all the possibilities? So if it's B, or if it's A, or if it's Y,
right?
Or if it's okay.
Yeah, we all understand. So you can.
So Z, if it's Y, if it's B or A. Just they all point to left.
Okay.
Is that right?
Yeah.
Okay. You keep going left. As soon as you find an A, then you.
So since you find X.
An X, yes. So if you read A, you kind of have to go back here, I think. Just
A is already there, so it should be X.
oh yeah.
No, this one should be X.
Oh yeah, yeah. You're right. So if you see X, just go right and start over.
Okay, and then what's the termination?
Like a reject state?
No, like an accept state. Like
Oh.
if you cross out everything and you see an X which is here, right?
Yes, yes. I have to self loop here. So if I keep seeing X's or Y's and Z's, then they all go right. And you just keep going right while it's X, Y, or Z.
Okay.
And as soon as I reach the blank, I just accept.
Well, it might be dangerous here because there are ramifications. Like you read X and Y's already, and then you see an A, then you go there. So to be on the safe side, you better create another state saying, yeah, I'm not going to do anything else.
Okay. So, like a reject state, kind of?
Accept states, I would say.
An accept state?
So if you're here and see a Y, then just go one way to see if there's anything.
Oh. So I'll write it here. So if I see X or Y or Z, go right.
Now, what's the case corresponds to? Corresponds to when the type is already X, Y, Z's, and your head is here.
Yeah.
Then,
Oh, the head. Yeah, the head is here.
so what do you do?
So as long as I see
Y and Z.
Y and Z's,
You go right.
I go right.
And you have to see Y first, right?
So I have to guarantee that. Yes. Okay. So it'll be Y. Only Y. Go right.
Yeah.
And while you see Y, go right, and then Z, right, like that. Do I need to do that?
Yes.
So here I have the X, the first X, and then all the Y's, and then all the Z's.
Right.
And then, sorry. Over here, accept here.
If it's a blank.
If it's blank, just right or something.
Yeah.
What do you think?
Let you take a look at my secret notes.
Okay.
It's this one. Exactly same.
I think I'm missing a few transitions here. There's like Y and Z here.
Oh,
I'm not sure.
yeah, it could be the case that it's already replaced by Y.
Okay. So
Yeah, it
here.
it corresponds to a case like this. So you won't, if you cross out this A,
Yeah.
you won't see a B. Instead, you see a
Oh,
Y.
there's no beat. You cannot do this transition.
Right.
Okay.
That's why you
So
have to do this.
Yes. Okay. Nice. Thanks.
Yes.
So we can, by just omitting all transitions to the reject state, it's
Yeah, you can kind of do that. It's on the same. Yes.
On the arrow that goes to Q accept, what is that transition? Is that like a W or something?
This one or
Well,
this one?
Or is that like space or?
Oh, yeah, it's a blank symbol. Basically, for all the place that has no strings, is blank. meaning that it's either the beginning or the end of the string. Yeah.
Why did we have the third transition from the start state 1 to off?
This one?
Yes.
After you cross out everything, you kind of try to say you want to accept this. Yes.
What about if you just give A, it has to reject, right?
Yes, if you just give A, it has to reject.
So we do need to have a condition from
in this is the
second
reject
state,
state.
right?
Yeah,
Reject state.
there's no reject state. Yeah.
Like,
Oh, anything that's not here, it rejects.
oh, is that by default, or do we not need to define it?
Well, strictly speaking, you need to define, but it's kind of understandable.
I asked Dr. Lee about it last class, and
Yeah.
he basically said you can assume that there are transitions to a reject state because you can, for Turing machines, we have to have a reject state, right?
Uh-huh.
So I was just curious because
Yeah, I'll assume wherever is not here, it leads to reject state.
So in that other kind of loop, that happens if you. How does that occur?
This one?
Yeah, how do you get to there?
Basically, when you cross out everything.
Okay.
And when you cross out everything, then you start from here. Right? And basically, what it says here is you keep going left until you see an X.
Okay.
So from here,
Yeah.
how do you decide that you want to accept?
Oh, then you have to make another loop to see that everything has been crossed out, and you have to.
Right, right. Basically, you make sure there's no B's and C's in the rest of the string.
Okay. I see.
Yes.
Can you use the only one symbol instead of X, Y, Z?
No, because then you might get confused between here or here. For example, you use X instead of Y. Then basically the going back loop will stop here instead of here. Sorry, it depends on how you write the rest of the Turing machine.
Yeah.
So in this one, it says if you read A, B, Y, Z, it keep going left. That means it stops when you see an X. So if you say X here, then the going back loop may end in here.
You change the first X to the blank, and then the rest of things change it to the only one X. You just need to find the first blank. So that's what the Dr. Lee did last class.
In my work, it depends on how, again, it depends on how you define the rest of the machine. But everybody understand this?
Yes.
Yes? Yeah, basically the algorithm is simple, right? The algorithm for the second one is very similar. So you want to guarantee the same number of zeros and ones. What's the algorithm? If you see a 0, then you keep going right to find a 1, cross it out and go back. If you see a 1, then you find a 0 and go back. It's the same, similar things, right? Now I'll ask you to do it. Yeah, once you understand the algorithm, writing down this is not difficult.
you'll just keep going right. And you won't find it. And he just
And the suggestion is try to play with some example first to see the idea. Can I erase this one now? Anybody still need it?
My question is, do you have, once you mark off a 0, and then you mark off the 1, do you have to go all the way back to the very beginning of the tape every single time? And is there a more efficient way so that you don't have to go to the beginning of the tape every time?
Yeah, I would say there is one. Because you don't need to remember what you mark off.
Okay, so then you can just continue and mark off the next 0.
I would say wherever that you mark off at the beginning, you give a symbol.
Okay.
And wherever you mark off at the end, you give a different symbol. So you just need to search for the first symbol.
Okay.
Let's do an example. First you see an X, you mark with X. Sorry, once you see a 0, you mark it with X. Then you keep going right to see a 1. Then you mark it off with a Y. Then you can go back to find the X. And you mark off this one with X. Go here to mark it with Y. And go back to find the X, which is here. Then you have to keep going right to find the first 0 or 1. Moody?
I have a question. If
Yes.
we put blank in the middle of a string,
Okay.
does that mean there's a blank symbol there, or does that mean it's like concatenating both strings? See what
There's only a blank symbol there. You can still keep crossing the blank to find the rest of the string.
Okay.
Misaligned string in the memory, you always have this side, 0. But it doesn't mean that your string stopped there. You can cross it to read out this.
So are you bounded by the X on the left, but you're not bounded on the
Right, you
on
cannot
the
bound it
right?
on the right.
Go past the Y?
Right. Kind of make sure it's only power 2 rounding algorithm. Okay, anyone wants to describe the algorithm?
Well, I have an idea for an algorithm.
Sure.
I don't know what exactly, but you start off by, I guess, noting what character you have,
Uh-huh.
0, 1.
Okay. So there'll be two cases, right?
Yeah.
So 0, what do?
You see with 0, you could mark it with an X and then start
Okay.
right. And then you gotta keep on looping to find a 1.
So you loop on zeros, right?
Yeah, loop on zeros, yeah. To find 1. So you keep on going right to find 1. So from there it's 1x, you gotta mark it off.
So you mark it with X.
Yeah,
Okay.
and then you can,
Then you have to go left,
yeah,
right?
then you have to go back.
So
And go back to the second character.
how do you know that it's the second character?
You keep on going back to from X.
But this can be the X you marked here.
But no, it has to be to the left of the X marked right there.
So you have to go back until you see an X.
Yeah.
Yeah, there is a bug in that algorithm because, for example, you mark this one with X, and you try to mark, okay, this is not a good example then. Yeah, basically, when you go back, you're not necessarily having all X here.
Okay. Then you should go back until you see the blank space again.
Okay, so you go back until you see a blank. Then what do you do?
Well, actually, yeah, you have to include 1 to that too, just in case. So you have to put 1 arrow L.
Here?
Yeah, right there, because my C1's like that.
I think it kind of guarantees that on this one, it's the first one you see on the tape.
Okay. Yeah, definitely. Yeah. Okay, so when you see the blank, then you keep on going right to find your X, so the initial X.
So they can only be X, right?
Yeah.
So if you see a 0, you go back here. If you see a 1, you go to a different branch.
Yeah, you have to start a new branch.
So basically, if you see a 1, you close it out. Similar things going on here. Would this describe what you have in mind? Would this describe what you have in mind?
Yeah, I just need a case for when it ends.
Right. When does it end?
I guess the case is when it ends is when it cycles through, like there's nothing but X's left because it costs about 1s and 0s, all the 1s and zeros. So you go back to the state where you go all the way left to the blank spot, and then you keep on cycling through the x's until you reach a blank spot again. To the right, keep on cycling right.
Like that.
Yeah.
This is the part that you keep going right on X.
Yeah.
Right?
Yeah, that's kind of like, yeah.
Objections? Matt?
So do we assume that the tape starts with a blank spot then?
Yeah, you can assume that because this tape always, the head is always on the left side of the string. Sorry, should be here. Yeah, but you can assume that wherever that's not on the tape is a blank. So that's Michael's solution. I just wrote it down.
Actually, we got a good counterexample.
Okay.
There are 0, 1s, and 0, 0s.
0, 1, 0, 0.
No, like there are no 1s, no 0s.
Oh, no ones and no zeros.
It's also the case that there are
Okay.
and
So if you're here and read the blank, then go here.
yeah, we can do that. So you need to add that, right?
Yeah.
So, from the start state, if you get a 1, you can still mark that with an X and go right?
Yeah.
Is that what you're saying?
Yeah. Basically, there's no distinction between the mark of X and whole 1. That requires you always go back to the blank.
Is it valid to assume that we have a blank space at the start of the game? The extreme left?
Yeah.
I can show like what I was thinking in a kind of more visual way. It's simple. Kind of informally, what I was thinking is that you look at this character first, right? Because it's the first one, and we know it's a 0. So we're just gonna keep on passing all the zeros until we find 1, and then we're gonna cross that out. So it's like this is crossed out, this is not crossed out. And then we're just gonna keep on cycling back, and then the question was, how do we know that we reached the beginning? First I said, oh, well, we're gonna keep on cycling back until we find X, but I guess you gotta find this one first, right? So that'd be wrong. So you keep on cycling back till you reach right here, reach the blank spot, and then you keep on going forward till you find a character again. So either 0 or 1, this time it's 0. So you're gonna get this 0, cross it out, and then you're gonna keep on cycling till you find a 1 again. So go right here, you'd skip that, you'd skip this, and then you find your 1, cross that out, and then you keep on cycling back till you find the empty spot again. So this is crossed out, this is crossed out, and then you keep on going forward until you reach your first character again, and that this time it's a 0, and then you cross it out, and then you keep on going back right until you find your 1, you cross that out, and you keep on going back till you found the empty spot again, so you're in the empty spot. And then like now the question is, how do you finish? Well, you know you're finished if you can keep on cycling through X's and you eventually reach the right and you reach an empty spot. So you just keep on cycling through X's and you reach this empty spot, and then it terminates steps.
And when you are asked, you can write this state diagram down there.
Eventually.
I can explain it really well. Yeah.
Yeah, well, yeah, then you have to explain it formally using state diagrams.
Yeah.
So it should be, Matt, it's easier than,
Yeah, it's easier than I thought it was.
yeah.
But the important thing is the marker at the start and
Right, basically the algorithm, how you determine the type has certain property. Right? Okay, I think I did sorry, I did the first one and Mike did the second one. There's a secret question, which was done by one of the class students. He sent a solution to Dr. Lee, and Dr. Lee asked me to explain it in the recitation section. But before that, I'll ask you guys to think about it first. Can I erase this one?
I have a quick question.
Yes.
Where you have that string x0y011, is that, what is that?
Sorry.
x0y011?
X0, Y011, yeah. It's just one of the intermediate strings during the algorithm.
Okay.
This is the solution. Okay, let me give the question. Write the Turing machine. You want me to discuss the algorithm, or you want to think about it first? Basically, how do you do multiplications?
You just talked about it. It is wrong.
So would the algorithm be something like a nested for loop, like for each A, start looking for B's, and then for each B that you find, match it up with a C?
Something like that.
And then, so you cross off an A, start looking for B's, cross off a B, find a matching C, go back, find another matching B.
But you already cross out the B. You have to revert it.
Yeah.
Is it? Yeah, metal is almost spit out. Is it clear to everybody, or do you want me to explain it again, or you want to think about it? You got it?
I think I have one. He said it in class.
Oh, he did? Okay.
Sorry?
One of the neighbors is covered. And both of them raise the same number of the seeds. You can try again and then fill it out. The neighbor will be a 10. And then raise the seed and go back and forth.
But he said like you had to like label the bees when you go over the bees. You have to label them with something.
Yes.
And then take that label off.
The label, write the label and then erase the label.
Okay, the two guys almost say it, so I'll explain it before they go further. First, once you see an A, it's same thing, the marking things. You first mark it off, and then you go right until you see the B's. How do you do multiplication? Basically, for each A, you find the same number of B's, and the same number should occur in C's. And sorry, what did I do? For each of, so you basically sum up the number of B's the times that equals the number of A's. So there are 2 A's here, so you sum up the number of B twice. So if you see an A, you want to mark off 3 C's, which is the number of B's. So how do you recall the number 3 here? Basically, you first mark out the first B, and go back to mark off 1 C, and then come back to Y to see how many B's left. So mark off this B, and then come here to mark off the C, and then come here to mark off the B, and then mark off the C's here. That's 1 iteration. And when you go back, you revert all the Y's into B's again. So when you go back, you replace all the Y by B's until you see an X. And then you do the iteration. Make sense? Now I'm not going to write the state diagram for you again. Can I erase this one now?
Can I ask a question?
Sure.
It seems like your transitions on this one are different than the form that we've seen.
Okay.
So the form that I'm expecting for this to me says if I see a 0 or an X, move right.
Oh, no, it says.
So
yeah.
What you're really saying here is if I see a 0, replace it with an X.
Replace it with
right.
X.
So shouldn't that be 0? Shouldn't that be that?
Yeah. You're right.
Okay. So that means if I see a 0,
replace it with
an X and
then
move right. But it should be more like that form.
Yeah.
Right? Okay. Sorry, I'm being nitpicky, but I was confused.
Oh, sorry.
So which one is correct? The one on the right or the one we wrote first?
Well, I think that's a notion that
that's the one in the book.
In the book, yeah. Then use this one.
Yeah, but different book use the.
Yeah, they override the symbols over again.
Okay.
Yeah, you use this one. Now can I erase it? You want to draw? I know it's a large picture. Like, which one is it?
This one.
Oh, okay. Draw. Oh yeah.
Should I explain you? So the reason A
Okay.
goes right till it's a B. Okay. Then again, if it's a B, it goes right till it's a C. And when it's a C, it will go left. If there are any more B's, then it will keep going left till it hits a B again. And if there are no more B's, then it will go right. No, it will go left.
You go left until you see a B. But then you basically cross out the last B's instead of.
What the last one?
So basically, you go left until you see the first B from the back.
Yeah. And you then keep going to left till you see A. And again you go left till you hit a X.
So for example, for the B one. Oh.
So you are here.
Yes.
You are at this B. You replace it with a Y. Go right till you see a C.
Oh, sorry.
Replace it with a Z. But that's
what's
a
the arrow?
back arrow. That's going from this state to this state. Okay. So from here it will go here.
Okay. So now you see a C.
Now I see a C.
Okay.
So now if it sees a Z, because we are replacing C with a Z. So if there are like Z's before the C, then it will go left. And whenever it sees a B, it will replace it with Y. Okay, so I need another state in between, so that it will keep going till it hits a Y and then okay.
No, but now you're going backward.
Yeah, I understand.
Right.
I need another state here. No problem.
Anyone has solution?
I
think I have way too many states.
How many do you have?
9.
9? Well, that's okay. Let me show you the solution.